All right, so in this video we're going to learn how to use the information you learned from the patty paper parabola to write the equation of a parabola from a graph. So this is the graph that you looked at with your patty paper parabola. We're just going to insert the different parts of this and label this. So starting out, this point that we have right here, this was our starting point with the patty paper, as well as this line right here. And that point is called your focus. And the line was called your directrix. All right, so then we have this line segment that goes from one side of your parabola to the other. That is going to be called your latus rectum. And then we have this point, which is the more familiar one. Oops, I labeled these in the wrong place. Let me fix this. This one is called your directrix. This point is called your vertex. And then we have the distance from your vertex to your focus is going to be labeled with the letter P. That represents a distance. And the distance from your vertex to your directrix is the same length. And the length of the latus rectum has a total length of absolute value of 4p. All right, so let's fill in some information here using the knowledge that you have now. The vertex form of a parabola that opens up or down is going to be in the format y is equal to a times x minus h squared plus k, where a is equal to 1 over 4p, and the vertex is going to be at hk. We have already talked about the transformations, knowing that h moves your vertex either left or right, k moves your vertex up or down. So those two things affect the location of your vertex. A is going to be your vertical stretch or compression, or it could be a reflection over the x-axis, and this is how you find the value of A. Remembering that P is the distance from your vertex to your focus, or from your vertex to your directrix, and you can get that information from the graph of your parabola. Now the vertex form for a parabola that opens left or right is going to be x equals a times y minus k squared plus h. A is still 1 over 4p, and the vertex is still at hk. However, your h and k have switched places. So keep that in mind when you are writing down what your vertex is. Okay. Now, in this situation up here on the first one, this parabola opens up or down, and if you think about y direction is up and down vertically. So if it's a y equals equation, it opens up or down. Up if your a value is positive, down if your a value is negative. X equals, well, the x direction is the x-axis, which is side to side. So you can think of an x equals equation opening either to the left or to the right, which is side to side. If a is positive, it's going to open up, to the right. If A is negative, it's going to open to the left, and we'll fill that in here in a minute. All right, so P is the distance from the vertex to the focus and from the vertex to the directrix. The latus rectum is the line that passes through the vertex and the focus. I'm sorry, the latus rectum is not correct on this. Let me fix this. The line that passes through the vertex and the focus and is perpendicular to the directrix is going to be called the axis of symmetry. And a lot of times I will abbreviate this as AOS. So if you have a parabola that looks like this, there's your vertex, there's your focus, and your directrix is right here. Your axis of symmetry is the vertical line that goes right there. It just splits your parabola in half. The parabola, if the parabola opens up or down, if the parabola opens down or to the left, then your A value will be negative. If the parabola opens up or to the right, then your A value will be positive. And the definition of a parabola is that it is the set of all points that are equidistant from a fixed point called the focus and a fixed line called the directrix. Make sure you know that definition. You'll see that again. And we talked about that in the patty paper parabola. All right, so let's now look at how you actually graph given some of this information. All right, so we're going to start out with the vertex at -2, 3. So we're just going to ahead plot that point, and I'm going to put a V next to that so that we remember that is the vertex. The directrix is at y equals 5, and y equals is a horizontal line. So 1, 2, 3, 4, 5, it's a horizontal line at 5. There's your directrix. Now remember that your vertex is halfway between your focus and your directrix, which means your focus is going to be located right here. So that we have the coordinate for now. That is -2, 1. Your parabola will always open away from your directrix. So what that means is that since our focus is right here, which is always on the inside of your parabola, and your parabola opens away from your directrix, your parabola is going to open like this. So that tells us our parabola is going to be opening down. We also know that if that is where the parabola is going to be located, that the axis of symmetry is going to be a vertical line, which would be x equals. It's going to be a vertical line that passes through the vertex because it has to split our parabola in half, and that would be at x equals -2. That would be your vertical line that goes right through here. Now the p value, if you remember, is the distance from the vertex to the focus and the vertex to the directrix. That distance here is 2. And if you'll recall, A is equal to 1 over 4p. And since our p value is 2, that means A would equal 1 over 4 times 2, which is 1/8. Now, since we know the parabola opens down, that means that our a value has to be a negative value. All right, so the length of the lattice rectum, that is absolute value of 4p, which would be 4 times 2 is 8. Now, if your lattice rectum is 8, and the lattice rectum passes through the focus, that means you're going to go 4 units on this side of the focus and 4 units on this side of the focus. Also remember, the distance from the focus to the directrix straight here will equal that same distance to the parabola on each side. So since it is 4 units from here to here, you can go 4 units this way and 4 units this way, and that'll give you 2 points that are on the parabola. And we can sketch what the parabola would look like here. The equation of this parabola, since it opens down, this will be a y equals equation. It's a vertical opening. The a value is negative 1/8, so that would be negative 1/8. The vertex is located at negative 2, 3. So if you'll remember, the vertex is hk. Our equation here is x minus h. Since our h value is a negative 2, that would turn this into x plus 2 squared, and the k value goes out here. Now your domain on this graph is negative infinity to infinity, and your range is from bottom to top, which is negative infinity. Now the directrix is not actually part of your graph. What we are finding the domain and range of is this curve. The directrix is not part of that curve. So that means our range goes up to a y value of 3. So we have negative infinity to 3. That's where the vertex is located, which means that is going to be a bracket. All right, so looking at the next one, we have a focus located at 2, 1. Put a little F right there for focus. And the directrix is at negative 4, and this is x equals negative 4. X equals is a vertical line. All right, now the focus to the directrix is a distance of 6. So if we split that in half, our vertex is located in the middle. All right, so the location of the vertex is at negative 1, 1. It also tells us the p-value is 3, because that's the distance from the focus to the vertex. And your a value is 1 over 4p, so that would be 1 over 12. Our parabola is going to be opening to the right, because that's going to be going away from the directrix, and that also puts the focus on the inside. And that means our a value will be positive. The direction of opening, we can go ahead and fill that in. That is going to be opening to the right. And the axis of symmetry is going to split our parabola in half. Right here, goes through the vertex every time. And since our parabola opens to the right, the axis of symmetry is going to be a horizontal line. And that horizontal line has an equation of y equals 1. So now the length of the lattice rectum, that is going to be 4p, which would be 4 times 3, or 12. And your equation, therefore, is going to be y equals a, which is 1/12. I'm sorry, not y equals. This is going to be x equals because it opens to the right. 1/12 y minus the k value. Now remember, your vertex is hk, so this would be y minus 1 squared plus h, and since our h value is a -1, that would be a minus 1 on the outside here. Now, we can also get our latus rectum on here and graph the parabola. The distance from the focus to the directrix is 6 units. That means you're going to go 6 units on each side of your focus to get to your parabola. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And our domain is from left to right, which would be -1 with a bracket, goes to the right forever. Range is bottom to top, which is -infinity to +infinity. All right, so the next one, we have the focus is given to us, and we can plot the information here. So the focus is at 4, 2, which is right here. The directrix is x equals 0. X equals is a vertical line, so right here is going to be our directrix. I'll put a little F right here next to the focus. Remember that your vertex is located halfway between the focus and the directrix, so this is your vertex right here. So our vertex we can fill in is going to be 2, 2. That tells us also that the p-value is 2. That's the distance from the vertex to the focus. And if p is 2, a is going to be 1/4 times 2, which is 1/8. We should be able to see that the parabola will open to the right. That means our a value is going to be positive. Your latus rectum is going to be 4p, which is 8. Opens to the right. Now, if you're going 4 units from the focus to the directrix, that means we can go 4 units up and 4 units down. And we can sketch the parabola here. And what that tells us then is the axis of symmetry is going to split this thing in half. It goes right through the focus and the vertex always. And so the line going this direction is going to be y equals 2. The domain is from left to right. It's going to be from 2 to infinity, and the range goes from -infinity to infinity. The equation, therefore, is going to be x equals, because we open to the right, a value, which is +1/8, y minus k, and your vertex is hk, so it's going to be y minus 2 squared plus h, which is 2. All right, and the last example that we have here, given the focus is at -1, -3, and the vertex is at -1, 0. Find all the information from this. All right, well, right away we can pick out the distance from the focus to the vertex is 3, and that is your p-value. A is 1 over 4 times that number, so that would be 1/12. And since the focus is always inside the parabola is going to have to open down, which means your A value will be negative, and this opens down. Now your axis of symmetry always goes through the focus and the vertex, which means it's a vertical line, so that's going to be x equals -1. Now the distance from the focus to the vertex is the same as the vertex to the directrix, and the vertex is halfway between the focus and the directrix. That means your directrix is going to be right up here. And that is at y equals 3. It's a horizontal line, which is always y equals. All right, the length of the lattice rectum is 4p, so that's going to be 4 times 3, which is 12. We're going 6 units to get from the focus to the directrix, which means I can go 6 units on each side of the focus to get to the parabola. So your parabola would be curved down like this. That's going to give us our equation. It opens down, which means our equation starts with y equals. Then we have A, which is -1/12, x minus h, and your h value is -1, so x plus 1 squared, plus k, and our k value is 0. And so that's going to be our equation. We have the domain going from -infinity to infinity, that's from left to right. The range going from bottom to top, and the highest or the largest y value on that graph is 0 with a bracket.